Okay, thanks for the introductions. It really sets the stage for what we're going to talk about here for what does that roadmap look like. And I feel honored, and it's also a pleasure to be in front of all of you and to have the panelists here that we have. This is a kind of a great crowd, and I'm excited to say I've spent a little bit of time with every one of the panelists during the 5G days that I started back in 2014. So I really appreciate this opportunity and then having this great group of people to go through this exercise. So I won't spend much time doing an introduction. The photographs are here and the titles. Do we have everybody on video fired up, Deshaun?
Let's see. I think there's one that is missing. Hold on one second.
Actually, Amitava, can you turn on your, unmute yourself? There you are. And Ali, I think I saw you, but I don't see you again.
I'm here.
Oh, we can hear you.
We don't see your video.
Okay. If you turn on your video, I'm going to go ahead and get started in the interest of time. This is a great group of folks. We've heard a little bit from most of them. We're going to hear a little bit more as time goes on. So for running a panel discussion, my approach really is to get right into the interaction with the team and to leverage the opportunity to get input from the audience as well. So you can read the bios on the web. I'm the only one that gets to do a slide intro. That's the privilege of being a moderator. I think that disagreement is where we all learn, and so I encourage a little bit of conflict on the panel, if at all possible. And I promise I will not mute anybody's microphone. And really appreciate any inputs from the audience. Keep your questions concise and make sure that they remain questions. The statements are interesting, but they're not as important as those that drive the discussion. So in the way of introduction, this concept of a 6G roadmap. So I did a little bit of, had a little bit of fun with this, and I was raised in a very small town in eastern Colorado called Simla. And I did a Google search for a Google Maps search for 6G and came up with at least one top hit, which is an address, 6G Brookside Heights, in a town that I cannot pronounce in New Jersey. For those of you who live there, I apologize. I don't know anything about this address other than the fact that it came up on the search. And I thought, well, how long would it take to get from Simla to 6G? And I came up with a few things. So first of all, there are at least 3 routes to get there, and you can see them here based on what Google Maps put together. The second thing is the distances are very similar, almost the same, just a bit more than 1,700 miles. And in fact, they all take about 26 hours. There is a lot of road work along the way that also courtesy of Google Maps and this wonderful artificial intelligence they put together, as well as crowdsourcing the data, helps us all understand where the problem places might be, at least on the primary route. Well, why is it that I bring this up? This is a little bit off topic, but I'm thinking about the same thing from the standpoint of 6G roadmaps. Now, you just heard a couple of presentations about timelines, and the keynotes this morning and yesterday morning each had their own flavor. I did a web search and grabbed several images off the web, and apologize if I don't necessarily have permission to show these in public, but the last one I'm showing is indeed one that I created for an internal slide myself. But I learned some similar things. There's at least 3 routes to get there. In fact, there's a lot more. The distances are very similar. There's a lot of work to be done. A lot of people are talking about the same things. They all appear to take about 10 years, maybe a little bit less if we're fortunate, like we were with 5G, to get started a bit early. And there's a lot of work along the way. So we're going to kick off the discussion from the standpoint of discussing what that work really looks like and how we as an industry can work together and also engage with academia and government to make the progress that we need to. This is my own slide about a summary of what is driving 6G, starting on the left, the market and the society that are driving expectations out of a mobile communications technology. The use models, this is a list of things that I picked out of ITU white papers, Charlie's white paper, the Samsung white paper, a few others. And then some comments about network architectures and demands and KPIs, all leading to a summary on the right of what the areas are where the technology will be developed and what we have to accomplish in terms of how do we take radio to its next generation? How do we develop a situation where multiple radio networks are collaborating with each other and we take full advantage of legacy as well as new use of spectrum? How we're going to evolve time engineering. We've talked a lot about low latency, but one of the things that got picked up in the ITU presentations and the Network 2030 work was not just low latency, but also very predictable latency. So maybe even a relatively high latency, but super precise timing from the standpoint of when information gets from client to server or client to client, even if the low latency is high. And that precise timing is a really difficult thing to do with the way the network has currently been designed. A lot of talk today and yesterday about various forms of artificial intelligence to optimize the networks and the increasing demand on security and privacy. So a good list of things that where I think from this is what's exciting to me about wireless is that it's not just radios. I think among all the areas where we could be involved as electrical engineers, the number of disciplines that we have to bring to bear crosses maybe a wider range than anything else we could expect. So with that in place, what I'd like to do then is start that panel discussion. And there's only one question that's teed up in the Q&A right now. We will get to that one. Gabriel, thanks for that one. But I'm going to seed the conversation with a couple other questions now that we have hopefully everybody present. So we talked, lots of folks so far at this event have spoken about what's really driving 6G and how it's going to be used. And then the ultimate question, do we really need these massive improvements in the various key performance indicators or network characteristics from that standpoint? So not everyone on the panel has had a chance to talk about this. So I'm going to actually ask Sujit to open with your comments on question number one, and tell us, based on what you've heard and what you're thinking, what really is driving this? Why should we be going down this path?
Thanks, Roger, and thanks, Amitabh, John, and Charlie, to demystify various things before, and excellent talks. I'll not answer the question, what is driving 6G? What is that killer app? Maybe directly like that. But I will say, and something that Charlie alluded to, and John and Amitabh also in varying degrees, is that we have a tremendous opportunity. I remember Charlie having said that AI has been sort of bolted on to 5G. Computing has been kind of bolted on to 5G. But a 6G, and I don't know whether it's 5G plus 6G, we have to look at the tremendous opportunities that it can give in the following ways. First of all, when edge computing becomes a reality, edge computing is at base station, edge computing is at gateways, but edge computing is down to the streets at the RSUs. Edge computing is at the IoTs at the street level. Edge computing is in your room, right? So there are varying degrees of edge computing. One of the opportunities and challenges is, now imagine a medical provider, imagine a entertainment provider like Diego from CBS Viacom. You heard him speak. He has been developing, he and his team, various different applications. Imagine, and he was saying that he wants to use edge computing and the 5G network. How will he program this network? How will he use edge computing? So we have had paradigms in parallel processing. We have had paradigms in distributed processing. We have to have that paradigm. which enables programming, dividing up the tasks. We heard of split computing, automatically doing split computing, automatically programming, maybe even have a layer of operating system, which can actually enable application developers to develop application on this very hierarchical edge computing, and then going into cloud computing, right? So network can be the computer, but we have to work on it so that we have scheduling techniques which are not focused just on RF scheduling, not on base station scheduling, but scheduling simultaneously RF resources as well as computing resources. So, so this is another opportunity and challenge I see. And the third one I'll say is all about data and AI. So yes, AI will be used and already being used to make the networks better perform. But I am envisioning intelligence as a service, because that's what is going to be needed. So when I'm writing, I'm a medical provider, I'm a transport provider, mobility provider. I'm quickly trying to launch an application, and I will need help with stacks, with intelligence stacks which are embedded into my network, and I'll be using them to actually write my program. I'll not want to develop new stacks of new models, new intelligence stacks in my, as I'm doing this. What if I already have those? So those are the opportunities. That is, hierarchical computing and distributed computing, embedded intelligence, which can be actually used by others, to write their programs, to write their applications, to launch their services, and data sharing and data virtualization, because those same nodes and same resources will be utilized by multiple different entities, multiple different enterprises. So like we have had an era of virtual computing, and then came software-defined network and virtual networking. I'm looking forward to virtualization of data and virtual data everything. And the combination of these three, together with the sensing that the network will do, and in combination with the other tools, I think will be a really. So now we are talking of not only a network, which is talking of which is thought of as bits and bytes and pipes, but a network which is an intelligent network. It's I don't know what to call it, but it's a cyber physical virtual network, because so many of the applications will be virtual applications, and the network is actually helping us in guiding us in terms of our decision making, helping us in terms of collaborative intelligence. That's the network I'm envisioning.
So I like that. And then let me ask Ali. You haven't had a chance to talk yet at the event. Give me your comments. Do we need those improvements in all those KPIs?
I mean, I think the good news is we're starting early, so we can question all these hypotheses every which way. I mean, we can say we need AI in the network, we don't need AI in the network, or the one in the middle, and that's all good. But now we have time. We, and especially academia, have time to look into it. I mean, we don't want to already have a dogma about what 6G is going to be and what is going to be in it. Of course, we can only think in so many dimensions. So today in the wireless world, we're looking at exciting technologies in adjacent worlds like AI and compute and distributed this and that. And we're saying, look, we can take these and put them in from the start. We can bake them in. They don't have to be bolted in. But of course, those technologies exist today. I mean, if we give ourselves enough chance, like we're calling it 10 years in our discussions, then we can question all of this stuff. So I think we should not take ourselves too literally when we say what's going to be in it, what's going to drive it. The important thing is to get started, and it takes a very long time in practice for all these wonderful technologies to find their place, right? It's not just enough to say, now we put it in. It has to do something. And hopefully, I mean, let's say 5G itself today, and with a couple more iterations, is already pretty good. So the threshold to cross is very high. This is why we need a lot of work along the way. I mean, you said there was a road work on your Google map, and I think that's a very good image.
Yeah, I think we do definitely have a ways to go. So let me then move to another question on this page, which is I've been asked this question before. I'm going to point this one at Amitabha. What's going on in 5G that is not meeting expectations and needs to get fixed in 6G? There's a loaded question for you.
Well, you say, as I said in my morning talk, that each new generation is about optimizing the new use cases of the previous generation. So in 5G, what is the use case? It is URLLC, ultra reliable low latency communication, and that has not been optimized in 5G, mainly for industrials. So I think in 6G, we'll optimize this ultra reliable low latency URLLC mainly for industrial IoT, which will be optimized for low cost and performance. Because industrial IoT will create new values, you see. So we have the old CSPs, we have all these old base stations, but you have to create new values. You have to sell more equipment, more base stations. So this industrials domain will have new value creation where we'll perfect URLLC in 6G. So that is my one sort of sentence answer. So I will say URLLC will make industrial IoT great again.
Very good. So I'm going to poke on that one a little bit. So then, John, from your perspective, is there anything else? Is there anything that's a technical requirement that's new to 6G?
Well, I think it's one of the things is the way we look at things like reliability and security. And so I think, these KPIs, we often feel that the ones as shown in the picture, they're very useful overall markers because we, never want to stop driving energy per bit. You never want to stop driving capacity because generally speaking, if the system can do more, future applications will come. If latency is better, it will become relevant to new types of connectivity. I think the interesting thing is when we kind of look beyond the typical cellular KPIs, the ones that have evolved from 3G into 4G, 4G into 5G, and say, okay, what are some other things that cellular can do better? And I think that's where we start getting into some interesting aspects with the intersection with the compute, even with some more kind of knowledge of certain types of services. So if we're trying to optimize the system for a future application, how much is that known at the physical layer? Think of things like QoS or think of things like 5G Wi-Fi or 6G Wi-Fi handoff and inner working. So there's always subtle ways of doing those things better. But I would say, the techniques we use, like data-driven design and really moving towards a more, machine learning approach to how algorithms are adjusted, what is the feedback? Those things will always continue. And I think it's really about how you put them together using the tools at the time. And so what's interesting from my standpoint is the tool chain is changing. Semiconductor process technology is changing, as Charlie pointed out as well. Like the RFIC rollouts, the fact that we're doing millimeter wave commercially now is very significant, and we're already obviously doing test chips for things like terahertz. So what's interesting is that the toolbox is changing, the KPIs are evolving, but at the same time, we're trying to make something that's commercially relevant. And so how we put them together from a cost structure, from a reliability structure, I think that's also where a lot of the kind of good engineering gets put into the design of the system.
So, and let me pick up on one of the things you mentioned too, John. There's a question in the Q&A. I'm going to go to this one first, direct this one to Charlie. And John hinted at this one. I love this question. Which G will stop me from losing connectivity every time I leave my house and fall off Wi-Fi? So help us with that one. Charlie, you have comments on that?
Which G will help stop the disconnection when you leave the house and fall off Wi-Fi?
Yeah.
A very good question. That's... I hope it's already solved, but if it's not, maybe we should look at what we're doing today. So this is probably not, there's a lot of the issues that's related to how to improve the actual experience of the final user that uses these technologies. How did you integrate them together, be it cellular or Wi-Fi? So a lot of times it's not really a, component technology issue. For example, cellular is already there, Wi-Fi is already there, but a lot of times it's software figure out the user's usage patterns, the preferences, and so on to make it more intelligent. I think I don't know what's the exact situation, but I also have experience that this choppy switch between Wi-Fi and cellular. Definitely, actually, our team worked on this topic of this intelligent Wi-Fi switching to cellular a few years ago, and we won this industry award, WBA award for Wi-Fi 6. It's kind of an interesting idea. It's exactly to address some of these issues. Is when you leave the house, how did you know whether you're really leaving or you're not leaving? So that's a challenge, right? So we were able to use this reinforcement learning, the Q learning algorithm to kind of learn what's the likelihood of this guy or this lady leaving the house for real. Because if he or she is not leaving and you disconnect from Wi-Fi, then you have another problem.
Yeah.
So that turned out to be a pretty good solution, robust solution. So I think, a lot of times, which also bring back to John's point earlier, it's not only about wireless, physical layer per se. It's also about how do you look at this technology solution from an end-to-end perspective. How did you put them all together? Not only cellular, 5G, 6G, but also Wi-Fi and the software. That's how you make a good product eventually.
I actually, for me, this is what this many nets thing is all about from Network 2030, which is the networks working a little bit more seamlessly. Sujit, you had a comment?
Oh, no, I was just saying that, this is a problem that has been there through all the Gs, Nick. It's a good question. The coverage holes. And
Yes.
we have researched on the coverage capacity trade-offs, but in terms of deployments, we have not only seen the coverage gaps continue and sometimes become wider actually as the more Gs have been deployed. So tremendous capacity here, but oops, no capacity in that hole, right?
Okay, so to comment on that, you see, so you have to densify your network. So coverage is very important. So the CSPs are looking for improving the coverage, and one of the ways to do it is to densify the network, right? So you get more base station, you get improved coverage, and you want to make the cost of deploying a base station much cheaper, you see. Otherwise, you have to look at the cost per revenue. So I think with 5G that is happening, that will happen, that you densify the network, improve the coverage, at least in release 18. We are keeping the KPIs the same, like we are not increasing the peak rate beyond 10 gigabits or latency less than millisecond. We are trying to improve the coverage and improve the EMBB to support XR where you need more reliability. So those are the things 5G and 5G evolution is doing. Improving the coverage is very critical, so that if we improve the coverage, it will get rid of all the holes in your call, you see, so a call will not drop.
As long as the handover works.
Availability. So, for medical applications, for instance, as through this pandemic, we've seen that more and more usage of telemedicine, right? Telehealth, telemedicine. And if you talk to a healthcare provider, of all things, the most important thing is availability. And so that's one thing, we need to also focus on. I'm hoping that 5G will have high availability, but definitely 6G, we should be having that as a very high KPI.
And I think that kind of underscores the importance of all the different spectrum bands, right? Saying, 5G added millimeter wave to, the LTE bands and obviously address low, mid, and high. Well, 6G is just going to add even higher bands. Absolutely, 6G will have to address all the bands to ensure we have good, as you're saying, good availability and excellent coverage. And I think that's one of the big challenges, is to ensure that.
Yeah, that's actually a pretty good segue to the technology space here. I'm going to jump to question number 4 here, or that relation, or it's close to the question that Gabriel asked. So we can get into this terahertz and terabit conversation just for a little bit. So Gabriel says, is 1 terabit per second per user, or per base station, or per sector? Let's give that one to John. What do you think?
I mean, I would say it's it's some sense of per user requirement. And what's interesting is as we go higher in frequency as well, the system becomes more directional. And historically, it's also become a little more TDM centric, time division multiplexing, partly because from an energy standpoint, you want to put your, you don't want to be spreading your power, particularly on the device transmit side, the uplink from the device to the network. At that point, when we're looking at the data rate, then being able to do that in a compact way is very important in the sense of getting that most energy efficiency. And so from my standpoint, what's interesting is how we can slice and dice data rate in 6G, and obviously even involving 5G, will involve a mixture of the definitions of per user, per sector will kind of change a little bit, particularly as we also bring in some increased use of kind of device to device topologies.
So on that, let me have a quick comment on. So with respect to terabit, so it is the peak rate, of course, right? So currently the peak rate in 5G is around 10 gigabits. So first of all, we have to see whether that makes sense. Do you need terabits? And so we did a theoretical calculation on what it takes to do a terabit, right? So you have the bandwidth, the MIMO channels, and modulation order. So if you look at the peak rate, these are the three variables you can vary. So imagine that at terahertz frequency, you have a 64 QAM modulation. Number of MIMO channels at terahertz frequency is say probably 2. So for that, you need around, to get terabits rate, you need around 250 gigahertz of bandwidth. So you can vary either bandwidth, number of MIMO channels, and modulation order to get the terabit peak rate. But we have to really seriously think it is just a number and why we need it. What are the applications or use cases which will drive it? But again, it is a function of bandwidth, number of MIMO channels, and modulation order. And I gave you an example that with 64 QAM modulation and number of MIMO streams, 2, you need around you need around 200, 250 gigahertz of bandwidth to achieve 1 terabit.
So let me move that one to Sujit. You're going to do research on 250 gigahertz ADCs, right?
Yes, that's Peter and Ian Galton's expertise. I don't know whether they're here or listening, but this was a question actually asked in a session yesterday. And I think that Roger, if I remember correctly, let's see, I think someone from Keysight asked, I forget. And Peter was saying that, yes, they will be looking at, but they're still not looking at it. And I don't know whether Gabriel is here. Gabriel is here, but he's not as a panelist. So maybe they can comment better.
It is. This is something we've started discussing as well, because obviously we have to do sampling, and when your sample rate and then the state-of-the-art clock rate for FPGAs or ASICs are widely divergent, then you end up with some serious challenges. So this is a territory that's going to need more work, I think. Let me switch real quick and go to the other end of the spectrum, if you will, in item number 2, and I'm going to point this one at Ali. Are we going to converge the RAN and the core? And how's that going to work?
I'm not sure what it means. I mean, their functions are quite understood today. I mean, sometimes we talk about flattening things, and it's mostly talking about the core itself. I mean, if you look at a 2G core, it was kind of more hierarchical. I don't know what exactly the question means. I think the important thing is that the functions are covered. Physically, of course, they can converge. We're doing more things that look more like cloud RAN, so they could sit in the same place. But
well, I guess I'll put it in context of the Open RAN model, the ORAN model that has this RAN intelligent controller that straddles the core and the RAN. Is that intersection going to become more amorphous in the 6G context?
Yeah, I mean, I think ORAN is not. I mean, ORAN and such those are current things that are well within the reach of 5G. So I don't think an ORAN question is a 6G question. And ORAN is fine, and it will define interfaces where, let's say, the 3GPP standards haven't, and that will be useful in some ways. But I think we always want to do cross-layer optimization. That's not the question, but I'm guessing a lot of people in the back of their mind want to do cross-layer optimization, and we have the layers for a reason. So I question that whole trend, I would say.
Amitabha, what do you think?
Well, you say open source is still in the works, right? So with ORAN, we have 7.2, 7.3, and what people want. So currently, you see the CU, DUs, and RUs were from the same vendor. So we want to break that chain so you can mix and match RUs and DUs from different vendors. So it is good. But one of the things you have to keep in mind that you shouldn't lose the coverage and capacity if you mix and match CU, RUs, and DUs, and you see. And the other thing they're looking at, right, on the front haul capacity, with there is these two architectures, 7.2 or 7.3, and with 64 TXRUs, you just couldn't support. There is not enough EC pre-capacity to support that kind of front haul. So you have to go to 7.3, where you bring a lot of the functionality back to the RU. So I think this ORAN will play part in 6G, where you are distributing the functionalities between CUs, DUs, and RUs, so you can mix and match. So people have a lot of flexibility in deploying a network.
Okay, thank you. I'm going to switch gears a little bit and go back to Charlie, and then I'll ask John as well. What does a 6G device look like?
Well, I hope actually there will be more than just a 6G device. There will be many different devices than what we can imagine today, right? So 10 years ago, when we started 5G, you have certain views of what the device look like, but today it's already quite different. I mean, it's still some of mainstream smartphone form factor continues, but we also have many other form factors showing up, including some of the AR, VR devices. So going forward, especially as IoT or industry IoT, to echo what Amitabha was saying, becomes more relevant and important. We really hope to see not just a device, really 6G become more universally applicable in many different areas of our life and society.
And I think what my comment would be, like similar to Charlie said, we kind of entered 5G with a similar mix of devices, but then already we saw, fixed wireless, CPE, repeater become more important, connected vehicles become more important. I think when we project out to the second half of 2020 and getting ready for those initial 6G devices, on the consumer side, one of the big things I see is the role of the evolution of augmented and virtual reality. So all of a sudden being hands-free, if you're a doctor, if you're working in logistics, if you're even co-creating in a visual immersive environment. So I feel that the computing interface is going to change substantially in the next 5 to 8 years. And so I do feel that the 6G devices that are used by people will be a little bit more intuitive from a user interface stand, and will definitely involve a mixture of augmented virtual reality, medical sensors, etc. And I think, as Charlie pointed out, the other aspect is that connecting the machines, if you will, whether you're connecting vehicles or connecting in a factory, that's actually going to result in a wider number of connectivity scenarios than those beyond human requirements for data rate and latency. It's not about shipping video around. It's also about shipping data around for machine learning. So I feel that the role of different types of connectivity modules, different types of, ways that we're bringing connectivity to a wider range of equipment. And that's also going to really change the form factor. It's going to change the number of antennas. It's going to change how we can leverage more frequency bands with different types of modules. So I'm pretty optimistic that what we're even going to see in the next 5 years, and then the 5 years after that, when we enter 6G, there's going to be a kind of a more significant mixture of devices than even most people will predict. Because I think these trends of the medical side and the AR VR side, it's getting a lot of investment and also a lot of interest. So I do feel there's going to be pull and a lot of innovation in that space.
If I may just add one thing, and I'll be so adding on to what Charlie and John was saying, but doing our role from academia, sort of dreaming big. I would love to have the confluence of these technologies, the displays, AR hologram based, things that are going on, to essentially have, you mentioned John, hands free, to not to use these devices most of the times, but rather to be able to communicate in free space, communicate, write, compose, and collaborate with others in free space. And that would be a perfect world for me, because then I can communicate with my wife sitting and make travel plans. Whereas I can communicate with you, while you are traveling, maybe in Canada, and so that is the kind of communication that I'm really looking forward to.
Okay, so we have just about looks like about 6 or 7 minutes left. I need to do a hard stop at the bottom of the hour, so I'm going to zoom in on question number 3 here. We could argue about the timing for a long time, but question number 3 is particularly relevant to this group, this audience, and that is the most important issues to be addressed by research, working with industry, and to some extent also government, because I think that's a key part of this as well. Policy, we do everything in the context of policy. So I'm going to ask everybody in the panel, I'm going to do a roundtable on this one to answer question number 3. Sujit, you have to go last. So if we run out of time, this is all about you knowing what the industry wants, right? So the pictures on my screen go in the following order: Charlie, John, Sujit, Amitabha, and Ali. So Charlie, you go first. What would you say is the most important thing that Sujit needs to work on with you?
Most important thing is to train good students, I guess. Make sure we have future engineers that's motivated and excited about wireless research, and will take things over from us a few years from now. So, But that aside, I mean, if you technical topics, that's really we can use some help. And as I also mentioned during the talk, the one thing is if we go to higher frequency in terahertz, right? The semiconductor side, we do see tremendous amount of challenges for RFIC, for ADC, with very large bandwidth. How did you make this happen? How did you make miniaturize the devices so that they can fit on this smartphone or maybe IoT device form factor? That's a lot of challenge, and I don't even know 1 decade will be enough. But I hope that if we start early, if enough people are motivated to look into this and investigate, we can make this happen. So that's one area we do see a lot of need. Definitely semiconductor, but also system. Terahertz and characteristics of the channel will be quite different. We have very little understanding of the channel in those bands this moment. There's already starting to see some research and measurement in this area for above 100 gigahertz. I think that's another area we do need a lot of help, especially from our friends in a university that has a lot of experience, doing channel model, doing measurements. Give us a good model. Let us know how to think about this. How do we come up with more engineering specs around the model that you provide?
Awesome. Thank you. John,
Yeah.
what do you think?
My quick feedback on that one is to focus on the fundamentals, that as we're looking at, how things are going to come together in 5G evolution, how things are going to come together more natively in 6G, the most important thing, in my view, from the academic industry side, is that the academics focus long enough term in terms of the foundational research. I think Charlie makes excellent point on the RF. There's a huge history of academics pushing the boundaries on RF research, whether it's efficient PAs, LNAs, like the entire RF chain. That's core to wireless. So what can we do better from an efficiency standpoint, and even enabling things like low latency immediately gets into things like duplexing, the role of TDD networks and fast switching and interference management, out-of-band emissions. So I think in the CWC context, that's an incredibly important example of an area where the academics can really be, 5-10 years in front of industry and keep pushing those boundaries hard.
Awesome. Thank you. Amitabha.
Yes, I agree with Charlie that RFIC research, which Gabriel is doing, at least in the terahertz band, how you control the heat, because if you want the same range, you need to increase the number of antenna elements. As you increase the number of antenna elements, you increase the ARP. As you increase the ARP, you generate heat. How to dissipate that kind of heat? How to do efficient PA at terahertz band? How to do efficient LNS. So I agree with John and Charlie on the RFIC research, which the universities will do. The other Q I am doing the university. Can you give me a positioning algorithm which will have less than 1 centimeter positioning accuracy? So that is a hard problem to solve. So I'll expect Sujit to give me that solution on how to achieve less than 1 centimeter of positioning accuracy. So,
All right. Marching orders. All right. So Ali, last but not least.
Yeah, I think the most important thing maybe that the best student get excited about working in wireless. So for that to happen, you need the academics to be able to look far enough and investigate really revolutionary stuff. I think that is a very important point. Of course, the students have to be trained and so on, and that will happen naturally. But we want the best students to be excited about our area. The other thing I think is always spectrum. There's never enough spectrum. We talked about terahertz and whatnot. I think we need to encourage more serious investigation into all kinds of spectrum sharing, all kinds of regulation, and so on. And of course, then it gets into RF and ADCs and all the goodies. But spectrum is always there.
Great. Thank you so much. So that's 1 minute to the bottom of the hour. I'm getting messages that say I need to wrap this. So first of all, allow me to thank everybody. And Sujit, thanks for the honor of being able to host this panel. And it's a great discussion. And then I'll hand it off to a close for Sujit for your comments, and then we can end the session.
Roger, there are some couple of questions on chat. If I may just quickly mention about academic industry collaboration. So one of the themes that emerged from day one and continued into day two in our forum is that the need for data. And one of the things that I picked up from one of the panelists from NTT Docomo, AI and wireless inseparable future panel, is that the reason the machine vision community have made so much progress in terms of doing research, and I'm talking of academic research, is because they have been able to come up with all these data sets. And if you look at the wireless academic research community, most of the research has been, and I'm talking of at a higher layer, not circuits, research, have been more on Wi-Fi. Wi-Fi based research has been very, very standard. And very little research can be done on cellular networks because of the lack of data and so on. Now, as more and more academic researchers at UCSD and elsewhere are doing more and more work on how to use AI to optimize networks and how to use networks to optimize AI, the lack of data has been an issue. Now, one of the ways of addressing that is to have these test beds. And UCSD also is, CWC is investing a lot of time and effort in creating these test beds. We are doing it, as many of you are aware, for the Smart Transportation Program for connected autonomous vehicles. But it's not possible for everyone to be doing these test beds. And we are fortunate to have partners like Keysight and Qualcomm and so on. But not everyone can do that. So one of the things we are also doing is creating digital twins. And this is something that I hope that industry and government and academia can come together in creating digital replicas, digital twin technologies, where we can not only have a few test beds nationally, but have these digital replicas, digital twins, which can replicate not only real situations, but where we can go into many, many corner cases, many different situations that we otherwise couldn't have, and also gather tremendous amounts of data that we usually cannot in real situations. For instance, driving, you cannot drive dangerously, right? And assess safety. Whereas in this digital replica, you can. So those are the kind of things that I expect in the next 10 years to happen a lot. A lot of movement towards creating these digital replicas, creating digital twins, and we sincerely hope that our industry partners and government partners will help academia and CWC.
Great, thank you. Do you want to take the time to answer the question, Sujit, or you're in charge of the board meeting as well?
Yes, I know, but there are a couple of, I think, a question from Mark. If you can maybe quickly have the panel discuss, maybe we'll run 1 minute late. And I see a question from Arthur. Do you see them?
Yeah, I do. So the first one from Arthur, if the future will not make use of more base stations, or are we going to leverage basically side-link and mesh type communications in the 6G space? I'll open that to any panelist that wants to touch that one.
Maybe I can just share a little bit of my view. So definitely, I think this new type of topology in mesh or other type of connectivity will be a very important part of the overall solution going forward. So if you look at the characteristics, especially in the higher frequency bands, really, it's highly directional, it's highly lossy. So the traditional way of thinking about designing it and the density that's necessary for that may not be scalable. So some form of mesh, some form of a new topology is definitely within a part of this consideration that's necessary to build it.
Okay, anybody else?
And I'll just add that what's interesting about the role of mesh and the longer term part is, when is it a peer-to-peer information exchange between people or even between machines? And I do feel that whether it's like integrated access and backhaul stuff that's part of release 16 already, to a more kind of disruptive use of mesh and relays. And so I do think we will obviously be adding 6G base stations over time as things get smaller and more compact, and particularly with disaggregation. But the role of topology research and leveraging side-link, I think, is also going to become more and more important, because it's what's going to enable that further proliferation to a larger number of connected devices.
That's right. Like D2D and V2X side links are currently being sort of standardized, right? But I will say in the immediate future that will be limited for public safety use cases, probably, not really in a wide scale cellular use case. So initially start with public safety kind of use case where you need this kind of peer-to-peer technology. In V2X applications for this, how to have V2X connectivity in a fleet situation, you see. So some limited use case in the immediate future.
So maybe that's a segue into the last question from Mark, which is, we haven't talked a lot about security. And so the question to any panelist willing to take this one on is, what role is the RAN going to play in security for endpoint protection? And I think this is particularly relevant if we're talking about mesh networks or things that approach that, but not necessarily.
I'll say we didn't talk about security because we are not a security expert. At least I am not.
Because we're on Zoom, right?
That was why I put it on the RAN part, Amitabha, because I figure that at least there should be some consideration there.
Yeah, but security is important, especially with the wide-scale use of IoT devices and use of micro base stations. I think it is important. But I will say with 5G, with industrials, it is will have a completely in-house or very the architecture will be within the enterprise. So I think security is important in the sense because of a lot of IoT devices. The base stations are going really small base stations, so security is important, but you see, the problem is I don't have the expertise in security. But
But I think what's a good question about it is that the reason like security is going to be increasingly important is the kind of the resiliency of the networks and the fact that we have security in silicon now, like a secure root of trust, even from a semiconductor timeline. And so what's interesting is when we talk of RAN and core, which I think Mark was getting at with the question, the other thing you need security in a way that has low latency as well. And so then all of a sudden, how you're implementing security, what you're relying on, how far you have to go to, authenticate and do those sorts of things. I think that's part of the virtualization. It's part of how we're able to efficiently implement it, because what matters more is mobility, latency, all those things. Even when someone's giving the example of, oh, there's a call drop, some weird handoff scenario, the important thing is then designing a secure system that has that kind of system that's not going to fail. Then all of a sudden, where you do security and how you do it absolutely is an important area of research.
I guess the other question I was thinking about was, we talk a lot about beamforming from a position of being able to overcome path loss and so on and so forth. Certainly in terms of pointing and selecting certain users, tracking and so on. But obviously that raises the other opportunity that, frankly, you could use it to basically only communicate or set up a secure link that could not be tapped into, or you've got a lot more control with that RAN, or that portion of the RAN at least. So I don't know if anybody's really started digging into that yet, but it does seem like an opportunity to particularly in some of these secure private networks as well. I know that they're supposed to all be on the enterprise campus, but as you know, wireless gets all over the place. So as long as you've got enough power, you could do enough damage.
Yeah, I think it has to be architected from the ground up, from all facets. But I agree. Yeah. Certainly, that's can work on some fundamentals. Any last comments? I am anxious to make sure we finish this on time. And Sujit let us go over, but I think he might have passed on to start the board meeting.
I think this was a great panel, and there is a never-ending discussion on this topic. And as Charlie and John knows, and Roger, you see, we are starting this next GA and Ali Alliance, where we'll have this university industry partnership. So watch out for that.
Happy to Amitabh participate.
There he is.
Say again?
No, I'm just saying that we'll be very happy.
Here.
Yeah.
That's great.
This is still here. Just perhaps, as one of the best technology for security based quantum communication, quantum technology. I'm surprised this quantum technology is not being mentioned at all in this forum. That's just my comment. Thank you.
Oh, that's our topic for next time, Sujit.
We sometimes, like I walk into the board meeting, and I'm absolutely sure some board members will ask me that why is it becoming a bigger and bigger tent, right? And some will want to focus. So we have various different drivers, and also our faculty and students. Wireless is expanding. Right? Wireless is expanding, with computing and AI and data virtualization, and then of course the technologies like terahertz and Theo, totally hear you, quantum computing. So there's lot to talk about.
Absolutely. Okay, so I think I'll wrap it there. Sujit, maybe I'll hand it off to you since this is the last session as a farewell. But thank you to all the panelists, and once again, I appreciate the opportunity here.
Thanks, Roger.
Yeah. Thanks, everybody.
Thanks to all of you panelists. Thanks.
Bye.
Bye.
And to all of you, including we have now the number of attendees attending on our Zoom link has gone down, but to all of us here as well as on IEEE TV, thank you very much for participating with us. And we always get a lot of feedback after these events, and please do send your feedback. Thank you.
Thanks.
And to our board members, we'll jump into the board call. Thanks.
Thanks, everyone.
The board members, you have separate Zoom links. Thanks.
Thanks,
Thank you.
everybody.